Hello everybody. In this video we are going to be looking at the solutions to the college prep sound homework problems 1 through 5. Let's take a look at problem number 1. How fast will a sound wave travel in air at 29 degrees Celsius? So we're given the temperature in degrees Celsius, and that's 29 degrees. And we're looking at how fast is the sound wave going to travel. I know that if I'm going to try to find the speed of the sound wave, I am going to need my temperature in Kelvin and not degrees Celsius. So the first thing I need to do is convert my temperature from Celsius to Kelvin. That is a pretty straightforward operation. To get the temperature in Kelvin, I simply take the temperature in Celsius and add 273 Kelvin to that. So to find my Kelvin temperature, I take 29 degrees, add 273 to that, and I'm going to have a temperature of 302 Kelvin. Now I simply take that temperature and plug it into my speed of sound in air formula. And I know the speed of the sound in air is going to equal 331 meters per second. Remember, that value is important because that is the speed of sound at 0 degrees Celsius. So I multiply that by the square root of my temperature in Kelvin divided by 273 Kelvin. And when I plug my temperature in Kelvin into that formula, I'm going to get a velocity of the sound wave of 348 meters per second. Problem number 2. A sound wave travels at 327 meters per second. What is the air temperature in degrees Celsius? So in this one, I am given the speed of the sound wave, 327 meters per second, and I'm being asked to find the temperature in degrees Celsius. I'm going to start off using my speed of sound in air formula. This time I need to rearrange it to solve for the temperature in Kelvin. And when I do that, I'm going to have the temperature in Kelvin is equal to 273 Kelvin times velocity squared divided by 331 meters per second squared. Just remember, in order to solve for T sub k here, because that's inside of my radical, I need to square everything. So I know that that is going to be squared, that is going to be squared, and then the radical goes away. So I'll just have 273 there. And when I do out that math, I'm going to have a temperature in Kelvin of 266 Kelvin. Now I'm being asked to find the temperature in degrees Celsius. So now I have to convert from Kelvin to Celsius. And as before, it's a very simple operation. To convert from Kelvin to Celsius, I simply take my Kelvin temperature and subtract 273 Kelvin. So 266 Kelvin minus 273 Kelvin is going to give me an air temperature of negative 7.00 degrees Celsius. Problem 3. A sound wave with a frequency of 267 hertz has a wavelength of 1.30 meters. What is the temperature of the air the sound wave is traveling through in degrees Celsius? In this problem, we are given the frequency of the wave, 267 hertz. We are given the wavelength of 1.30 meters, and we're being asked to find the temperature in degrees Celsius. If I'm being asked to find the temperature, I know I'm going to need to know the speed of the wave, which I am not given, but I am given the frequency and the wavelength. And I can use my wave speed formula with those two quantities to determine the speed of the wave and then plug that into my speed of sound formula. So to find the speed of the wave, I simply multiply the frequency times the wavelength, so 267 hertz times 1.30 meters will give me a speed of the sound wave of 347 meters per second. Now I can plug that into my speed of sound formula, again solving that for the temperature. And that will give me a temperature of 300 Kelvin. So I have the temperature. It does give me the temperature in Kelvin. And remember, this temperature right here always has to be in Kelvin. So we just have to be careful of that. We can't plug Celsius temperatures into that formula. That is one of the more common mistakes with this formula. So again, to convert from Kelvin to Celsius, I simply take my Kelvin temperature, subtract 273 Kelvin from that. So 300 Kelvin minus 273 Kelvin will give me an air temperature of 27.0 degrees Celsius. Problem 4. A sound wave travels a distance of 1,460 meters in 4.32 seconds. What is the air temperature in degrees Celsius? So we are given the distance of the sound wave travels, 1,460 meters. We are given the time it takes to travel that distance is 4.32 seconds. And we are being asked to find the air temperature in degrees Celsius. Once again, we're going to need to know the velocity of the sound wave. But in this case, we're not given the frequency of the wavelength, but we are given the distance it travels and the time it takes to travel there. And I know my velocity formula is simply velocity equals distance divided by time. That's an oldie but a goodie from a long time ago, but it still works, so we're going to use it. So 1,460 meters divided by 4.32 seconds will give me a velocity of 338 meters per second. Now I can plug that into my wave speed formula. And when I plug that value into my wave speed formula, I am going to get a temperature of 285 Kelvin. Now I have to convert that temperature to Celsius. So once again, I just take my Kelvin temperature, subtract 273 Kelvin from that. So 285 minus 273 will give me an air temperature of 12.0 degrees Celsius. Problem number 5. How many seconds will it take an echo to reach your ears if you yell toward a mountain 65 meters away on a day where the air temperature is 34 degrees Celsius? So the distance between you and the cliff is 65 meters. The air temperature is 34 degrees Celsius, and they are looking for the time it's going to take for the echo to reach your ears. This problem is a little tricky for one reason. The distance between you and the cliff is 65 meters. So if here's the cliff and this is you, here you are, and you shout, here's 65 meters, by the way. This, by the way, is not drawn to scale. You guys can remember how bad of an artist I am. But if that is 65 meters, the sound wave is going to have to travel from you to the cliff, which is 65 meters, but then bounce off the cliff and then travel back to your ears. So the distance the sound wave needs to travel is twice the distance between you and the cliff, because it has to go from you to the cliff and then back from the cliff back to you. So to get the total distance the sound wave travels, I have to take my distance and multiply that by 2. So 65 meters times 2 is going to be 130 meters. So now I have the total distance. I need to find the total time. I know I'm going to need the velocity, and that I can get from the temperature. So first thing I need to do is convert my temperature from Celsius to Kelvin. So I take my air temperature of 34 degrees, add 273 K to that. When I do that, I'm going to get an air temperature of 307 Kelvin. Now I can plug that into my wave speed formula, and when I do that, I will get a speed of the sound wave of 351 meters per second. So I know my total distance, I know my velocity, now I can find the time. And I know the time is equal to the distance divided by the velocity. So to find the total time the sound wave travels, I take my total distance of 130 meters, I divide it by my speed of 351 meters per second, and that will give me a time of 0.37 seconds.